Hello. In this video, we will talk about Learning Objective 2, Define BIM. Associated questions are, what is BIM and what is not BIM? So we'll do this by conduct an internet search first. Here's a list of selected definitions or results I received from my internet search. I will pause here or suggest you to pause here as long as you need to in order to read through all these four definitions. All right, so let's take a look at these four definitions and see what keywords come to your mind, or at least some keywords keep showing up in all these four boxes or in multiple boxes here. I highlighted them in different colors. As you can see, we end up seeing terms such as building information modeling, building information models. We also see keywords such as process, digital representations, virtual equivalents, and also see keywords such as physical and functional characteristics. So let's summarize and paraphrase the definition of BIM from our perspective. First of all, BIM is a process as well as a technological platform. As a process and also with the enabling platform, this process leads to the creation of a digital representation of something. And here something is a facility, being it a bridge, road, or building. And this digital representation is capable of supporting all the activities throughout its life cycle, including design, construction, operation, and demolition. So we view BIM as an intelligent simulation of architecture with 6 key characteristics. First, it's digital. We are not talking about the paper drawings. Second, it's spatial. So every building element has a location and also 3D geometry. Third, it's measurable. Measurable means that we are looking at each individual object. We can quantify, we can measure their dimensions, and we can ask questions about these objects and query and search through. Fourth, it's comprehensive. So comprehensive means that as a resulting digital representation, it should include your design intent, building performance, constructability, and the sequential and financial aspects of means and methods. It should be accessible or accessible. Accessible means that people of the different, remember we talk about the different people from different organizations, they all play a role in a project. They should all be able to access your model. And it's durable, which means it's robust and resilient, and it can be used throughout all phases of your facility life, including starting from the programming to design to construction to operation and maintenance, and finally towards demolition. So let's digest the term or the terms further, right? So the first thing came to my mind is building. So when we think about the building, we can view this building as a noun or as the ing format of a verb. So when we're thinking about it, this actually comes or stems back to build as a verb. What you're going to be looking at is a process. And in this process, we can use this one to represent our construction planning, right? So what you do first, what you construct first, what you construct second. So this is a process. Building as a noun, it refers to a product, an end result. So this product, you can be looking at a design product, right? You have a design of a building. Or it's the product of your construction. So you get the physical building back. So the process of developing this digital representation is modeling. And the end result is the model, right? So the model contains a lot of information, and such information as a digital representation, it shall cover both the physical and the functional logical capabilities or functionality of your end result. So all these together, as a digital representation, it enables communication, coordination, and collaboration through all life cycle stages. And as your project progresses, you have a few milestones. When you complete your design, your BIM model becomes an as-designed model. When you complete construction, it becomes an as-built. When you're going through the operation and the maintenance, it goes as maintained, right? So in between them, as during the construction process, usually takes a couple years long, you're looking at a continuously evolving and a changing model. So at that part, we can call that as constructed. So let's define our own BIM, shall we? Right? We have gone through quite a lot of definitions about the BIM, some interpretation, and the deciphering of the meaning of the terms and putting them together. So let's first look at the BIM. In this core class context, we define BIM as both of building information modeling and also building information model. So keep in mind, modeling is a process. This is the process you actually develop your virtual or digital and also the physical model. And your model itself is the end product. As at the end of the design phase, it's the as-designed model. And when you complete your construction, that's the physical product you get. So BIM is a modeling technology and associated set of processes to produce, communicate, and analyze building models. Again, we want to emphasize building refers to both the end product, the physical facilities, or the construction process, such as constructing, right? The sequence you take, the money you spend, the means and the methods. Building components are represented with digital representations. These are called objects. Objects have graphical and data or actual property attributes and behavior data. Consistent and non-redundant data, such that changes to component data are represented in all views. We are working on a single central model that is the base for various views. So BIM represents a coordinated structure to represent all views of a model in an organized and logical manner. Any BIM as a system, as a technology, as a process, as an end result, should contain or has three key technical characteristics. First, object-oriented modeling. Second, parametric objects. And third, central database. We will come back to revisit these three key concepts throughout the class as we progress. So here's a few examples to show that the BIM model, the end result, is a digital representation of real facilities. The pictures on top these are the BIM models. These are the models that we design through BIM authoring tools. They look very neat, right? But I hope everybody can tell that they are not the real ones, right? They are not the real ones. At the bottom, we have the construction results. So the left picture shows it's during the construction phase. We still have some plastic covering right here. And the right side takes another view angle, and you still have some plastic covering over there. All right, still have some plastic covering over there. So by just looking at these few examples, we have a few observations. First, by looking at the BIM models themselves, we use them in the design phase. What we will be able to see is what we expect to get, right? So this allows us to appreciate what we are going to be getting or know exactly what we are building before before you set the stone or before you set the brick over there. Now, during the construction phase, right? During the construction phase, you can compare your as constructed product to your as built. This allows you to monitor your progress, what has been built already, what is ongoing, what still needs to go onto the job site, and allow you to perform quality control, which means you're comparing your digital model to your physical model, and you get to detect and analyze the discrepancies. And once you complete your construction, the BIM model evolves into the complete as-built model, and this provides rich information during the operation and the maintenance stage, right? So, and the most important part is that it provides information for those covered and also visible components. So thinking about the scenario where you have a pipe leak, and the pipe is buried, inside the wall, so you won't be able to tell what's going on there. And if you don't have a BIM model, you don't have any record, you have no idea what is the type of the model, the specification for the piece that you need to go in and replace the broken one, right? And you won't be able to see it unless you cut it, open that up. This is going to be a very time-consuming process. Now, on the other hand, you look at your digital model, you know exactly what you need. You go to the job site, you don't have to come back again, bring all the necessary components and parts with you and get the job fixed. And if you want to extend that further, you can even simulate the whole processing or the repairing process and gathering all the tools. And you can also optimize the repairing process to reach or achieve the overall systematic optimal performance. So another key concept that is very important, because BIM is a rich information model, it serves as a central model and a database. This central model and database does not only apply to the design phase, allow different disciplines to coordinate and collaborate working on the same model. Rather, it can be extended into the construction phase, as we said many times, right? So here's a few slides to show you that based on a given model in the center right here, given this model right here, you can develop your drawings, your 2D drawings, if you like to see. You can also do quantity takeoff and monitor your cost progress and to do cost control or cost management. You can also look at how much work you need to do, look at your work scope, develop work breakdown structure, and sequence your activities for your scheduling. And you can also do cost estimating. That's part of the cost management as well. So what's the beauty of having a central database, a central model and a database? As you have a central database, right? So first of all parties are looking at the same thing. Second, all applications are always retrieving the same set of information. And third, you can have a mechanism to integrate them together. You're not just looking at the physical components being built. You can also look at how much I'm spending on each individual component, how much time I spend on each one, and help you identify the problems and also secure all the material supplies onto the job site in real time. And BIM oftentimes is also the base that supports a concept called the lean construction, something very similar to just the in-time production system. So object-oriented modeling and the parametric modeling, right? These are also very important. These are actually the essential concepts behind the modern day building information modeling. So when we talk about the parametric BIM objects, first of all, your objects have attributes, properties, and behavior and function or performance. Similar to us human beings, right? We are also objects, but we are human objects. As a human, we have attributes, properties, for example, your height, your weight, your eye color, your hair color, and so on and so forth. But you also have behavior function, right? So you eat, you sleep, you walk, you study, you learn, and the list can go on. BIM objects, they are intelligent objects. They can do similar things. Now, when we talk about the parametric rules, right, or parametric modeling, so parametric modeling is based on parametric rules. These rules enable objects to automatically modify associated geometries as necessary. So for example, a door fits automatically into a wall. This is part of topological rules. In BIM model, in your design, you will never see a wall or you will never see a door that floats somewhere without being part of a wall. A wall automatically resizes itself to butt to a ceiling or roof. This is also topological rules. A wall automatically resizes itself based on dimensions. This is called the geometric rules. So if you specify the height, the width, the thickness of the wall will adjust its size automatically. So the list can go on. Parametric rules and object-oriented modeling allow the modeling work in BIM to be extremely efficient and rewarding. So we talk about the BIM, right? So what is not BIM? Well, models that contain 3D data only and no object attributes. Models with no support of behavior. Models that are composed of multiple 2D CAD reference files that must be combined to define the building. Models that allow changes to dimensions in one view that are not automatically reflected in other views, and so on and so forth. So the key point of what we are saying here is that if your practice or if your models are not object-oriented, are not parametric modeling enabled, are not a central database, then it's not BIM. All right. So let's pause and take an exercise, do a case study, a case analysis. And for this one, I will not read through the whole case study. I suggest that you pause and read and complete this case study on yourself and submit it after class.